Welcome to this class. Today I am continuing the chapter Simple Machine of the subject Science and Technology of class 9, and this is part 3, and we are going to focus on this inclined plane. Okay, before this inclined plane, I want to recall the types of machine first, and then we'll continue with inclined plane. Do you remember there are 6 different types of machine, but actually it is reduced to 4 types of machine because 2 of them comes under inclined plane. Okay, now let's start. First, lever, second, pulley, third, inclined plane, and fourth, wheel and axle. Why I left gap between inclined plane and wheel and axle? Because screw and weighs are taken under inclined plane because they are modified version of inclined plane. That's why screw and weighs is taken as inclined plane. So first we have to remember that lever, pulley, inclined plane and wheel and axle are simple machine. In first class, I mean to say part 1, you are taught about mechanical advantage, velocity ratio and efficiency in terms of this lever. And in second part, I told you about the pulley, definition of pulley, example of pulley and velocity ratio of pulley, advantages of pulley and numerical problems related to pulley was taught in second part. Now this is first part and we are doing just the inclined plane, not screw and weighs also. What is inclined plane? What are the example of inclined plane? What advantages can be taken from inclined plane as a simple machine? And what are the numerical problem related to inclined plane? How can we calculate MA, VR and efficiency in inclined plane? Okay, I want to start with some example, with some diagram. Look at the diagram. This is inclined plane. A flat, rigid surface is inclined at an angle to the horizontal or the ground. And why this type of flat rigid surface is made or set just in front of a house or just in front of an office, we can answer this way. Actually this is an inclined plane, that's why the planning is to carry heavy load into this office or into this house, and heavy load cannot be shifted or cannot be transferred to this room by these steps, because steps disturbs the carry of the heavy load, and that's why we can use the wheel on this flat surface and heavy load can be easily carried to this office or house, whatever it is. This is example of inclined plane. Now there are other example also. Look at this. This is the slide which is normally seen in the children's playground. This is another example of inclined plane. This is another example of inclined plane, but not the truck, not the man, not the drum. The inclined plane is the plank, this plank which is used to carry load into the truck. Okay, now this is slopy road, and slopy road is also considered as inclined plane. I want to show you one interesting slopy road. This is the slopy roads of Sinduli highway, and there is a selfie hill also. People used to take selfie photograph here. It's very nice appearance, but we are related to just the slopy road which is actually the inclined plane. Looking at all this, now how can we define inclined plane? What is inclined plane? If you are told what is inclined plane, then you have to write or you have to say the definition of inclined plane. We can define inclined plane this way. Inclined plane is a simple machine which consists of a flat and rigid surface inclined at an angle to the horizontal and is used to carry heavy load to the height. Looking at this definition, have you noticed this? There are certain points highlighted. It is simple machine and it consists of flat rigid surface. We have to include all these in definition and the definition becomes very, very good. See, it is simple machine, it is a flat and rigid surface and it always makes angle with the horizontal and it is used to carry heavy load. this is the use is also included in the definition. If we define like this definition will be very nice. Okay. Now, if you are told to write the example of this inclined plane, or if you are told to say the example, then there are some examples which are very important. First, plank used to carry the load into the truck is one of the best example of inclined plane. All over the world it is used, and this is slopy road. Slopy road is considered as inclined plane. Actually, this road makes certain angle with the horizontal. And third, you can say slide of children's playground. These three are very, very important. That's why I want to focus on these three especially. Okay, I told you definition also. I told you the example also. Now it's time to make the diagram of inclined plane. If you are told to draw diagram of inclined plane, how do you draw this diagram? Look at this. It looks like a right angle triangle, and inclined plane is used to pull a load on the surface of the inclined plane, and this is the load, and direction of load is towards the center of the earth, because load is the weight. Weight means the pulling force of the earth acting on a body is weight of that body, and this weight is taken as load in simple machine. We usually say load. Now it is pulled on the surface of the inclined plane from one end to the another in this way, and so the length through which the load is pulled is called effort distance. This load is pulled to this distance from this point to this point. That's why the whole length of the inclined plane is considered as effort distance, because effort is applied from this point to this point. And at the same time, the load is raised to this much height. The vertical height, I mean to say the vertical distance from horizontal to the final position of the body, that is the load, is taken as load distance. In short, what can we say? Effort distance is the length of the inclined plane, and load distance is the height of the inclined plane, because we usually pull a body from one end to another end of the inclined plane. That's why length is effort distance and height is load distance. Okay, now finally I want to show you the diagram which we have to draw in our notes and our examination. This is the real diagram. If you are told to draw the diagram, then the components of the inclined plane should be shown in the diagram. There are four basic components. One is load, another is effort, another is effort distance, that is the length of inclined plane, and the last one is load distance, that is the height. These four are the basic components of the inclined plane, and it looks like a right angle triangle. This is the diagram, very nice diagram for the representation of an inclined plane. Okay, I told you about the diagram also. Now we have to understand mechanical advantage, velocity ratio, and this efficiency related to inclined plane. These three terms are very important, and they were taught in part 1, MA, VR and efficiency. Now I want to tell you MA, VR and efficiency in terms of inclined plane. For every simple machine, whether it is lever or pulley or wheel and axle or inclined plane, in all the cases mechanical advantage is same. The ratio of load to the effort is called mechanical advantage. MA equal to load by effort. This is same for every simple machine. In the same way, efficiency is also same for every simple machine. Efficiency means the ratio of mechanical advantage to the velocity ratio expressed in percentage. Efficiency, which is denoted by eta, equal to MA by VR into 100%. It can be represented this way also. There is another definition also. Efficiency equal to, I mean to say, efficiency is the ratio of work output to the work input expressed in percentage. We can write eta equal to work output upon work input into 100%. This is also same for every simple machine. It was taught in part 1. Now I am going to I am going to tell you about the velocity ratio. Velocity ratio is different in different simple machine. In case of inclined plane, the velocity ratio is the ratio of effort distance to the load distance. That means the distance from effort to the fulcrum is effort distance, and distance from fulcrum to the load is called load distance, and the ratio of these two is taken as velocity ratio in lever. But in case of pulley system, the number of segments of the string supporting the load is taken as what? Velocity ratio. In this case also it is a little different. What is it? Velocity ratio of inclined plane is this. The ratio of length of the inclined plane to the height of the inclined plane is called velocity ratio of the inclined plane, because length of the inclined plane is effort distance and height of the inclined plane is load distance, and ratio of effort distance to the load distance is actually velocity ratio. That's why in case of inclined plane, the ratio of length of inclined plane to the height of the inclined plane is velocity ratio. It is represented by this equation, this formula. Okay, I told you about the velocity ratio also. Now, what are the advantages of inclined plane as a simple machine? There are 3 basic advantages of simple machine. Number 1, it magnifies the effort. Number 2, it increases the speed of the work. Number 3, it changes the direction of force. These are 3 basic advantages of simple machine. Out of these 3, we can get 2 advantages of simple machine from this inclined plane. What are they and how? Look at this. Advantages of simple machine. Magnification of effort. What it mean? If we use inclined plane to raise a load, then less effort will be able to raise heavy load. That simple machine, I mean to say, in inclined plane magnifies the effort. Now, another advantage is change of direction of force. Simple machine, in case of inclined plane changes the direction of force towards the convenient direction. Now, how it is possible? Let's go to a little detail. Magnification of effort is possible in simple machine only when effort distance is longer than load distance. It was told in previous class. Now, according to principle of simple machine, effort times effort distance is equal to load times load distance if the machine is considered to be frictionless. Now, what is our concern? What I told you just now, this inclined plane magnifies the effort. It means it must have longer effort distance than the load distance. And how it magnifies the effort when effort distance is longer than load distance? We can take some mathematical explanation also. This is inclined plane, and this is the effort distance, and this is the load distance. Effort distance is always longer than the load distance in inclined plane because it seems to be a right angle triangle, and hypotenuse is taken as effort distance, which is always greater than the perpendicular. So, effort distance is always greater than load distance in case of inclined plane. Okay, then how it magnifies the effort if effort distance is more? We can take some mathematical values. Look at this. If effort distance is considered to be 2 meter, then certainly load distance is less. I am taking it as 1 meter. And if 1 Newton effort is applied in left hand side, what happens? The product of 1 Newton and 2 meter becomes what? 2 joule. 2 joule is in left hand side. It must be equal to right hand side. To be 2 joule in right hand side, the load must be 2. If this equation is correct, this equation is certainly correct because this is the principle of machine. That's why to be equal, load should be 2 Newton. And if it is 2 Newton, then we will have 2 joule in right hand side also. So, what is the conclusion? In inclined plane, effort distance is always longer, it is taken as 2 meter, than that of the load distance taken as 1 meter only. effort distance is always longer than the load distance. So less effort, 1 Newton only, will be able to raise heavy load 2 Newton. This is the conclusion. It means in any simple machine, if effort distance is greater than the load distance, then less effort will be able to raise heavy load. It is mathematically, we can prove this mathematically also like this. Okay, now I think you are clear about the magnification of effort, why inclined plane magnifies the effort. Now second matter I want to introduce, change of direction of force. What is its meaning? Meaning is this, like this, we can understand with the help of diagram. So I'm presenting this diagram. Here this is inclined plane and this is load, and if we want to raise it upward, then certainly we have to apply force in the upward direction, but in inclined plane we are applying force in this direction. We are applying in this direction, force is applying in this direction. If inclined plane was not used, then certainly direction of force will be vertically upward like this. So because of the use of this inclined plane, direction of force is changed to this direction instead of vertically upward. This is convenient direction for us. It is very easy to pull or push a body on the inclined plane than that of the direct picking up the body in the vertically upward direction. So this inclined plane changes the direction of force in the convenient direction. This is second advantage of simple machine which we can take from inclined plane. Okay, now I want to conclude. We can take just two advantages of simple machine from this inclined plane. One, magnification of effort. Second, what? Change of direction of force. But third advantage cannot be taken from this inclined plane. The increase in the speed of the walk is not possible. To increase the speed of the walk, load distance should be longer than the effort distance, and here this is the load distance and it is always less than effort distance. It never be greater than effort distance. That's why this advantage cannot be taken from this inclined plane. Okay, now I want to tell you some more information about the inclined plane. I want to relate load distance, effort distance, and the angle of inclined plane with horizontal. Let's do it. This is a little detail. You will have very good idea if we relate load distance, effort distance, and the angle made by the inclined plane with horizontal. Look at this. When length of inclined plane, that is effort distance, increases like this, in first case it is less, in second case it is a little more, in third case it is more than second case. And in each of the case, the length of the inclined plane, that is effort distance, is increasing. And height is same. Look at this. Taking height constant, we are increasing effort distance. Length here it is less, it is more here, and here the maximum among these three. Now if length of the inclined plane is increased, keeping the height constant, then what will be the effect on the angle of inclined plane with horizontal? This angle. This angle, here it is like this, but in second case the angle is, now what happened? Angle is decreased. In third case, angle is decreased. It means if the length of the inclined plane is increased, keeping the height constant, then angle of inclined plane with the horizontal keeps on decreasing. Okay, we can conclude this. Angle of inclined plane with horizontal decreases when length of inclined plane increases. And what it means, if length of inclined plane is increased, then less effort will be able to pull the heavy load. All this inclined plane helps us to pull heavy load by using less effort. But the same load can be pulled by using less effort in case of second than that of the first, and same load is if pulled on the third inclined plane, it requires more or less effort. If 100 Newton force is applied to pull a body on this inclined plane, here it will be less, maybe only 80 Newton. Here it will be more or less, maybe only 50 Newton, because effort distance is increasing, angle of inclined plane with the horizontal is decreasing, and it helps to pull heavy load with less effort. Okay. Now, what happens when height increases? I mean to say load distance is if increased, what will be the effect? Look at this. This is first inclined plane. Here height is a little less. Here height is more. Here height is more than the second also. This length of inclined plane is taken constant. I mean to say it is not changed. Length of inclined plane is taken same. Length is same in all the inclined plane. But height is increased. In first case height is less. Second case a little more, and third case a little more. Effort distance is constant. Load distance is increasing. Now, what will be its effect on the angle? This angle seems to be less if compared with this angle. Look at this, it is a little more, and this angle is more than the second also. It means when load distance increases, I mean to say increased, keeping the effort distance constant, then the angle between the inclined plane and horizontal keeps on increasing. And what will be the effect of this in the effort applied on the inclined plane? Here effort distance is same in all the cases. Load distance is being increased. It means if load distance is increased, amount of effort required to pull that body will increase. If 100 Newton force is applied to pull something on this inclined plane, in this case it requires more than 100 Newton, 120 Newton maybe, and in this case more than 120 Newton, maybe 150 Newton, because this load distance is increasing, effort distance is not increasing. But in all the cases we can use less effort to raise heavy load, to pull heavy load. The reason is effort distance is always greater than load distance. But how much greater? This is declared by the load distance also. Okay. Now we can conclude this way. Angle of inclined plane with horizontal increases when height increases. Okay. We are talking a little detail about the inclined plane. I told you definition also. I told you how to make the diagram also, what are the advantages also, and different components of the inclined plane, this effort distance and load distance, how they are related and how it is related to the angle also. Now let's take a break. Now the break means I want to present one question, and this is question break. Look at this question related to the same inclined plane. Till now what we studied, this is taken in this question. This is the statement about the inclined plane. Inclined plane magnifies the force and increases the speed of the work. Is it correct? Just evaluate it. If you cannot, I am here to say the answer. This is the statement. Now one argument is added on it. What is it? Effort distance is always greater than the load distance in the inclined plane, so it increases the speed of the work. Is this correct? Now just think about this. I am giving you time to think about this. Okay. Next, argument 2, it is added on 1. Load distance is always less than effort distance in the simple machine, I mean to say inclined plane, so a heavy load can be pulled by the less effort in the inclined plane. Looking at all these statement and argument, you have to decide which option is correct. Only statement is correct, or only argument 1 is correct, or only argument 2 is correct, or statement and both the arguments are correct. You have given 4 different options. Now you have to select one of the correct option. Now let's go through first option. Only statement is correct. Check it out. Inclined plane magnifies the force. Yes, this is correct. And increases the speed of the work. No, this is incorrect. To increase the speed of the work, load distance should be greater than the effort distance. But in all the inclined plane, effort distance is always longer than the load distance. That's why increase of speed of the work is not possible. This statement is not correct. So I want to drop this number 1. Only statement is correct. This option is not correct, incorrect. Okay, now let's go through 2. Only argument 1 is correct. Is it? Look at this. Effort distance is always greater than the load distance. Yes, this part is okay. In the inclined plane, yes. So it increases the speed of the work. Again, something wrong. Half of the statement argument is okay, but so it increases the speed of the work. No. Effort distance is longer than load distance, so it magnifies the force, not increases the speed of the work. Argument 1 is also incorrect. So only argument 1 is correct. This option, I want to drop it down because this is not correct. Only argument 2 is correct. Is this? Okay, let's check it out. Argument 2. Load distance is always less than the effort distance. Yes, effort distance is always greater, load distance is always less. In the inclined plane, yes, this part is okay. So a heavy load can be pulled by the less effort in the inclined plane. Yes, this is also correct because load distance is less, effort distance is more. If effort distance is more in any simple machine, then less effort will be able to raise heavy load. Effort is magnified. This option is correct. It means the second argument is correct, means this number 3, option number 3, only argument 2 is correct. Now what about 4? Statement and both argument are correct. No, it's not correct because statement is wrong. I told you previously. So we'll tick on the option number 3. This way we can understand a little detail about the inclined plane. This type of question, if presented, then you'll be able to identify everything related to inclined plane, load distance, effort distance, advantage, etc. Now after this question, I want to take you to numerical problem. Let's go to numerical problem. Because we have the formula for mechanical advantage, velocity ratio also, and we know efficiency also. All these are taught in part 1 a little. I changed velocity ratio in this case also. Now using those, we are going to calculate MAVR and efficiency in case of inclined plane. Look at this. Length and height of an inclined plane is 1.3 meter and 32.5 centimeter respectively. A load of 270 Newton is pulled from one end to another of the inclined plane using an effort of 90 Newton. Calculate the following terms. What are the following terms? Mechanical advantage, velocity ratio, productive work. Productive work means work output. And invested work. Invested work means work input. And number 5, efficiency. The 5 questions are asked. Now I want to solve this numerical problem. Look at the board. Okay, I'm writing the information given in the numerical problem. Length and height of inclined plane is 1.3 meter and 32.5 centimeter respectively. Length is 1.3 meter, which can be represented by effort distance. It means effort distance is equal to 1.3 meter because we know that length of the inclined plane is effort distance. Now next information is what? Height of the inclined plane. It is 32.5 centimeter. Height means load distance. Load distance is equal to 32.5 centimeter. It is given in different unit. Now first I want to write this. A load of 270 Newton. Load is 270 Newton. And what is another information? We can use how much force? This 90 Newton force. I mean to say effort is 90 Newton. These are the information given, and calculate the following one by one. Mechanical advantage we have to calculate first. In question number 1, it is given mechanical advantage. Mechanical advantage is equal to question mark. Now we have what? Mechanical advantage equal to load by effort, and load is 270 Newton and effort is 90 Newton. Newton cancel, 0 cancel, 9 3s are 27. Therefore, I can say that mechanical advantage is equal to 3. What it mean? It means using 3 times less effort will be able to raise the load. If there is 300 Newton load, then it can be raised by using just 100 Newton effort. Effort will magnify by 3 times. Mechanical advantage is 3. Now second, velocity ratio VR is equal to question mark. Now what is the equation for VR? Velocity ratio equal to effort distance upon load distance. Now effort distance is 1.3 meter and load distance is 32.5 centimeter. Here is a little contrast. One is given in meter, another is given in centimeter. That's why we have to either convert this meter into centimeter or centimeter into meter. So I want to convert meter into centimeter. If 1.3 is multiplied by 100, then it comes in centimeter. So if multiplied by 100, we will get 130 centimeter. You can use calculator, and divided by 32.5 centimeter. Now centimeter cancel. Now I am using calculator. If we divide 130 by 32.5, now 130 divided by 32.5, this is equal to 4. Velocity ratio is 4. Therefore, I can conclude VR is equal to 4. What it means? Effort covers 4 times greater distance than that of the load. It means if we have to raise a load by 1 meter height, we have to pull the load on the inclined plane by 4 meter length. This is the meaning of this velocity ratio 4. Now let's go to another part. Third is productive work. What it is? Productive work means work output. I am writing thirdly, productive work. It means work output. Work output is equal to load into load distance. And what is the load? 270 Newton. 270 Newton into load distance. What is the value of load distance? 32.5 centimeter. Now here a little twist. Centimeter doesn't work because work done is measured in joule and Newton meter is joule. Newton centimeter is not joule. That's why we have to convert centimeter into meter. So how can we convert this? 270 Newton, if it is divided by 100, then we'll get in meter, because centimeter is a small quantity. I mean to say small unit has to be converted to bigger unit, and it is possible only by division, and division should be made by the relation is of 100. 1 meter equal to 100 centimeter. That's why I'm dividing with 100. Okay, now what happens? Now 270 Newton into, if it is divided by 100, then you will get 0.325. I can write this very easily. If we cut this, then decimal point shifted to 1 digit left hand side. If we cut another, decimal point shifted to another. But you can use this calculator. This is the number 270 into 0.325. Now I am going to multiply this. 270 into 270 into 0.325. 0.325. This is equal to 87.75. 87.75. This is equal to 87.75. Newton meter is joule. That's why work output or productive work is 87.75 joule. Now let's go to number 4. Number 4, this was 3. Now number 4 is what? Invested work input. Invested work. This is equal to effort times effort distance. I'm writing directly because all these are taught in previous class. What is work output, what is work input, etc., etc., mechanical advantage, velocity ratio, all are done in previous class. That's why I'm writing directly the formula. Okay. If effort is 90 Newton and effort distance is 1.3 meter, now multiplying this, 13 9s are 117, yes, Newton meter joule. Okay, 117 joule is the invested work. Invested work is always greater than the productive work. Now last one, efficiency. What is it? Number 5, efficiency is the question. Now efficiency is equal to, we can use any formula, MA by VR into 100% or work output by work input into 100%. Both of them are equally correct. MA is found 3, VR is found 4 into 100%, and 4 1s are 4, 4 2s are 8, 4 5s are 25, 3s are 75%. This is the final answer of this efficiency. Now this way we can calculate the efficiency also. I did one numerical problem. Now I want to go through another numerical problem also, because this simple machine is related to MA, VR and efficiency and numerical problem. That's why I look at this another numerical problem. Efficiency of an inclined plane having length and height 2.6 meter and 65 centimeter, effort distance and load distance are given respectively, is found to be, efficiency is found to be 75%. What amount of load can be pulled on a surface using 45 Newton effort? Okay, now I'm going to write all this information on the board and I'll solve the numerical. You also think about this, how to solve this. Okay, first information is what? Effort distance 2.6 meter, load distance 65 centimeter. That's why I'm writing the same. Effort distance is equal to 2.6 meter and load distance is equal to 65 centimeter. One is given in meter, another is given in centimeter. If necessary, we'll convert centimeter into meter or meter into centimeter. And eta is the efficiency, it is 75%. Now, what amount of load can be pulled on a surface using 45 Newton effort? Effort is given, this is 45 Newton, and what amount of load can be pulled? Means load is question. Now how can we solve this numerical problem? It's very easy. When we convert the sentence of the numerical problem into mathematical form, then we don't have to see the sentence in the numerical problem. Now looking at this, you can use this formula. We have eta is equal to your mechanical advantage upon velocity ratio into 100%. Yes. Now I want to elaborate this. Eta is equal to 75% and mechanical advantage is load by effort and velocity ratio is effort distance by load distance and multiplied by 100%. Okay, we are writing value. Now this percentage cancel. 25 3s are 25 4s are. Yes, here is 3, there is 4, and 3 or 3 is equal to load, we have to calculate, and effort is given here 45 Newton, and in denominator we have effort distance 2.6 meter and load distance also given 65 centimeter. We can convert directly this 65 here, also we can convert if it is divided by 100, then centimeter comes in meter. This is equal to 0.65. And here we can write directly 0.65 meter, okay, into 4. Or 3 is equal to, if load and 45 Newton effort is taken in denominator, and it goes like this, 0.65 meter upon 2.6 meter, meter cancel, into 4. Okay, let's go to this place. Now this is equal to, I want to put this load in one of the side. That's why everything is, if taken to left hand side, then what we get, 3 is in left hand side, 45 Newton into 2.6, I want to take it to left hand side, 45 Newton into 2.6. Now only 0.65 and 4 is left in right hand side. 0.65 goes down and 4 also goes down in denominator, and this is equal to what? Load. Load is taken in right hand side. Now we are using calculator. We can use calculator easily and we will get the answer. Okay, what we are doing now, we are multiplying 3 with 45 and again with 2.6. The result is 351, and I can write this load in one of the side. This is equal to 351 Newton divided by 0.65 into 4. 0.65 into 4 is equal to 2.6. This is equal to 2.6. If we divide 351 is divided by 2.6, then we'll get 135. Therefore, load is equal to 135 Newton. This is our answer. Okay, we solved one numerical problem. Look at this numerical problem. Seems to be a little difficult, but not difficult, because if we scare with the numerical problem, then it becomes difficult. If we write the information, then it becomes easier. Okay, I think today's time is finished. I started inclined plane. I finished the inclined plane with his definition also told, and its characteristic according to simple machine, and what are the advantages, what are the example, what are the numerical problem. I think you can now reproduce this to another place also. Okay, today this much. Thank you.